So let's look at a couple where we've got some information and we want to figure out what the equation of the graph is. I'm going to start with number 30. So they're giving us the vertex and they're giving us the focus. So let's draw a picture. The vertex is at 4, -2. I'll call this V. And the focus is at 6, -2. Okay, well, we know the focus has to live inside. So we know this thing is going to have to open to the right. So since it opens to the right, it's going to have a very specific format. And if you remember, and go back a few pages, it's going to open to the right. It's got to look something like this. Okay. Now, because we have the vertex and the focus, we also know what A is going to be. So let's write down everything we know, going back to where it was. So opens to the right. It's got to fit this format. Y minus k squared equals 4a times x minus h. So we know h is 4. K is -2. That's your x and y from the vertex. And if we know the focus is here at 6, 2, we know A. A is the distance from here to here, vertex to focus, and that is 2. So our equation, if we substitute everything in, y minus -2 squared equals 4 times 2 times x minus 4. Simplify. And there's our equation. Okay, let's do another one. Let's look at number 34. It's going to help if you draw a picture on these. So 34, they're giving us the focus and the directrix. So let's draw a picture. So our focus is at 2, 4. The directrix is the line x equals -4. So, and this line has the point -4, 4 on it. Okay. Now the reason I wouldn't want to know that is because I know that the vertex has to live in between these 2 points. So I need to find the midpoint. So the midpoint equation is going to be x1 plus x2 over 2, y1 plus y2 over 2. So this point was at 2, 4. So 2 plus -4 over 2. So you're really just averaging the x's, right? And we know the y's. So we're going to have -2 over 2, which is at -1. And we know that this is going to be -8 over 2 is -4. So there's our vertex. Okay, well, that makes sense. If we were just to look at this picture a little bit, there would be our midpoint. So we also know what A is going to be. A is the distance from here to here, which is 3 units, or here to here, which is 3. So we've got this nice picture. We could use that to figure out that vertex without having to do the midpoint. But if these were not nice numbers, then you would want to use the midpoint formula. So we know the vertex. We know A is 3. We also know which way is this going to open. It's got to open again to the right because that focus has to live inside of that quadratic. So format, same as the last one. Substitute in what we know. And there's our equation. Let's do another one. Let's say we have this one. We'll do 58. Okay, now we have the vertex and we have just a point on the graph, but we have enough information to figure everything out. So the vertex is at 0, -1. It opens up. So going back to our charts, if it opens up, it's going to have this format. So as of right now, here's the equation that we have. X minus 0 squared equals 4a times y minus -1. I'm going to clean that up. That's going to be x squared equals 4a times y plus 1. Okay, but this is where this is going to come in. We do not have a vertex. We do not have a directrix. So we've got to use that point to figure out what a is. So we're going to plug in x is 2 and y is 0 to find a. So 4 equals 4a times 1. So we know a is going to be 1. So then our equation, we're going to go back to here. Actually, I'm going to use the step below that since that's simplified. We're going to have x squared equals 4 times 1 times y plus 1. X squared equals 4 times y plus 1. So there's the equation that fits that. All right, the last thing we're going to do in this section is a word problem. So a long time ago, the satellite dishes used to be shaped like a parabola if you were to take a cross section. Now they're more elliptical shaped, which gives you better reception because you're going to have two foci in there. But they used to be, well, they used to kind of look like a bowl, right? Something like that. And then there was a point at which you would have this receiver, and that would bring in all the different signals. Okay, and it would focus there. Well, the reason they use that design is because if we were to take a cross section, so if we were to a knife and just kind of cut this in half, right? Just cut out a little sliver there. It's going to be shaped like a parabola. So let's look at this example. A cable TV receiving dish is in the shape of a paraboloid of revolution. So that's a parabola that's been revolved and it's a three-dimensional thing. Kind of looks like a flattened bowl, if you will. Find the location of the receiver, which is placed at the focus if the dish is 6 feet across and its opening is 2 feet down. So we want to find where that receiver would be. We could take that picture, take that cross section, which would be if we were to cut out just a little sliver here where that focus would be, and we can put that on the Cartesian plane. Now, if we want to model this, it's going to be easier if we model this guy so that the quadratic opens up and centered at 0, 0. So we know some points. If this has to be 6 feet across and 2 feet deep, then this point would be at 3, 2, and this point would be at -3, 2. Okay, so that would give me that distance of 6 feet across and that height of 2 feet, height being the y value there. So we can take all of this information and we can figure out where the focus is going to be. We're opening this up. It's centered at 0, 0. And we could center it anywhere we wanted to on the Cartesian plane and draw the picture, but it's going to be easier if you think about this with a vertex at the origin. So going back to our format for something that opens up centered at the origin, in these equations, you may, when you create your cheat sheet for this chapter, you may want to make sure you have these handy. So you may want to copy those down on your cheat sheet. So there's our format. We know the vertex is at 0, 0. So if I plug 0, 0 in here, I'm going to have a 0 here and a 0 here. I'm going to have x squared equals 4a times y. Now, to figure out where that focus is going to be, we need to figure out the a value. And that's where the points on the graph are going to come in handy. It's going to be really similar to that last problem that we just did. So we're going to plug in the x coordinate and we're going to plug in the y coordinate. So there's our A value. A is, remember, how far we are from the vertex. In this case, we would want to be above. So we're going to be at 9/8 here. That's that distance. So then the focus is going to be 9/8 of a foot, which is 1.125 feet from the center of the base, which is the vertex. So when they're creating all of these, they would find that vertex, which would be easy to do, right? When you have that three-dimensional figure, and they would go 1.125 feet above, and that's how far that distance would be for that receiver. So that's how long that rod would need to be to hold that receiver in place.